Okay, we spent some time in the past videos examining the gamma function and some of its basic properties. In the last two videos, we were able to prove that the gamma function of 1/2 is equal to the square root of pi. In the first video, we established this relationship that the gamma function of n plus 1 equals n times the gamma function of n. In fact, that's equal to n factorial. So the gamma function of n plus 1, if we use our basic definition, replace n with n plus 1 minus 1, that's x to the n, e to the minus x dx. That's now another definition for n factorial. So for example, if we had this integral here of x to the fifth e to the minus x dx, we know right away what the solution to that is. It would just be 5 factorial. What we want to do in this video and in the next one is consider some gamma type integrals and see how we can solve them. For example, suppose we had this integral here that we had to solve. Integral from 0 to infinity of x to the 1/2 times e to the minus x cubed dx. And we see, well, that's sort of like a gamma function, except here we have e to the minus x cubed. So our temptation would be, well, maybe we can use a u du type substitution, and when we do that, maybe that will come out to resemble then a gamma integral. So we'd start off saying, well, let u be equal to x cubed. So du will equal 3 times x squared dx. Now what we want to do here is replace the dx in this integral here, so we can say, well, dx, divide both sides of the equation, that would equal 1/3 times x to the minus 1/2 times du. That's true, but we want to have this side of the equation expressed entirely in terms of the variable u. We don't want to have an x on this side. So we go back to our original substitution. As looking at this, we would say, well, u to the 1/3 that would equal x. So x to the minus 1/2, that would be equal u to the minus 2/3. So we go over to here, we say, therefore, dx will equal 1/3 times u to the minus 2/3 du. So we have dx is replaced by this. E to the minus x cubed would be e to the minus u. We still have this term here. Well, u to the 1/3 equals x. So x to the 1/2, I raise this side of the equation to 1/2. I raise this by 1/2. That will give me u to the 1/6. Now, x cubed equals u. If x is 0, u is 0. If x is infinity, u is infinity. So this equation here we can write as x to the 1/2, that's u to the 1/6. E to the minus x cubed, that's e to the minus u. Dx, that's 1/3 u to the minus 2/3 du. Let's take the 1/3 to the outside. This goes from 0 to infinity. U to the 1/6, this would be u to the minus 4/6 du. And this will equal 1/3 integral from 0 to infinity. 1/6 minus 4/6, that's u to the minus 3/6. That's u to the minus 1/2 times e to the minus u du. So this integral here is equal to this, and hopefully by now you recognize, wait a minute, that right there, this integral right here, that's the gamma function of 1/2, and we know what that is. That's the square root of pi. So ultimately what we're going to end up with is this integral here that will equal the square root of pi divided by 3. And that's it. So again, we started off with something that sort of was like a gamma integral. We said, well, maybe if we do a u du substitution, we can get lucky, and it will become a gamma integral. And after we made the appropriate substitutions, we had this, and of course, hopefully by now you can recognize that. That's the gamma function of 1/2, which is the square root of pi. So we're able to solve this integral. So come back, join us for another video, and let's see if we can solve some more problems.